So, good morning, all. In the last lecture, what we had done is, in fact, a small and a brief description of the different kinds of questions normally we are encountering in the learning process of microeconomics. So we started asking the very preliminary questions like what is microeconomics, then what is actually different aspects, and what is an individual, how do we expect to be an individual under economics, especially microeconomics framework, etc. So today what we are going to do is directly going to the details of what we are going to deal with the subject in that sense. So as you may be having your syllabus with you, right? All of you having your syllabus, right? Yeah. So have you gone through the syllabus? Uh, have you gone through the syllabus? If you have actually noticed, the first module comprises of different topics such as preference and utility as the first one, then followed by budget constraint and other things, and maximization, minimization problems, etc. Okay, so we are going to have a lecture today based on the first module's first topic, which is called the preference and utility. So within that, let me come to the preferences in the first instance. Okay, so with this, let me come to the problem. Now, have you heard about preference? Have you heard about preference? Okay, what is preference? Tell me something about preference very quickly. Anyone? Hmm? Preference is priority. Okay. Anybody else? Any other point? Okay. So I don't want to actually keep lengthening this question as well as your answer because it is taking too much time. Now let me come to the point. Unless and until we interact, it is very bad to have a lecture online in this way. Okay, because it will become monotonous. That's what I keep asking question. Okay, for me also there is no incentive if you, in fact, don't ask any question. So preference. Can you ask? Can I ask another question? What is choice? Have you heard about choice? Hello. So what is the difference between choice and preference? Okay. Choice is actually you. Okay. Fine. Anybody else want to comment? Anything else? Anything? One more chance. Okay, very good. So preference, and I'm very glad that none of you has disagreement. So the preference is exactly what you people said. Preference is actually a series of it's a choice set. So you have different kinds of preferences, like you may liking apple, you may liking orange, maybe all these are called your preferences. So then if you rank your preference and according to that, then you go for the thing which is you want, then that has become a choice. Excellent point. So thank you for the thing. But in order to make such preferences normally, so in that sense, preference is a larger set. It is actually having more options than when it comes to the choice. So choice have actually something which, as you said, limited to what you want at that particular point, and that is the final ultimate choice. Someone pointed. So it is very interesting that people have both preferences as well as the choices. So when you have the final one, then that is called choice. So this is about what we are going to discuss in the entire consumer preference, because when I say that a consumer preference, consumer has actually a lot of likes, as you said. So there are many likes, so out of that likes people pick something. Once you make that a decision, then that decision is called a choice. So you have different type of preferences. Out of that preference you pick something, so that comprises of your choice set. So that's it. So for that, actually people have different sort of um, preconditioned or predetermined sort of criteria. So even when I am saying that I have preference, lot of constraints, or what we say, a lot of other concerns. In fact, we bring in the economic understanding. Same the case with the choice also. We do have this differences, and that differences, out of that difference and constraints, we pick something, and that picking up is what is called the choice. So that is how it has been dealt with. So in a very simplistic sense, when you have a preference set, out of that you can also have a choice set. So choice set is also your preferred set in that sense. Okay. So when, as I said, you have different concerns. Let us first define what are the concerns, and before making such any other concerns, let us define what is an individual. As in the last lecture I was asking you, so unless you have an individual who has characterized properly, or whoever it is been characterized properly, it is very difficult to actually understand the problem which we are dealing with. So why this is because you want to basically standardize the individual, and then we see that standardized individual preference and his choices, etc., or her choices, etc., and how that is going to affect the decision, or the production, consumption, or whatever. So this is what is actually in a nutshell we are going to understand at the end of the whole point. So before, as a part of this thing, there are different parameters or criteria being laid or understood as to make a person a standard uh, consumer. So we in the last lecture I asked what is a consumer. So the consumer is someone who is actually consumes. So what would be the characteristics of, so somebody said in the last lecture that the profit maximizing person, utility maximizing person, etc. So that means the individual which we are speaking about definitely has sort of or having a sort of particular characteristics. So now that characteristics should be normalized. So that normalization is what we have to initially do. Then only you go for what is that normalized individual's preference and choice. So this is the first thing. So have you heard about the axioms called rational choice axioms? Anyone? Other than the point which was shown here, like completeness. Have you heard about the axioms of rational choice? Excuse me? Anyone? Okay, fine. The first one is called the reflexive axiom. Very simple axiom. We know that if I am preferring X, then I have to prefer X over X. All right. So at any condition, if I am saying that X is I like X, then I have to say every point that I like X. So X is preferred by itself. So this is what is called X. So in a simple sense, you can see that an apple can be called as an apple, not an orange or something else. So if you identify something as apple, you have to call it as apple, and you say attribute, you try to give an attribute of that kind. So X is, oh, in a conceptual framework, somebody can say XRX is X is preferred to X itself. So this is what is called a reflexive axiom. So simple. In a movie like Kilikam and all, somebody asks, okay, what is this uh, powder tin? Then the person says this is apple. So that has not been the case here. So when you actually show that, okay, what is this thing, then that is actually trying to prove that your mental conditions are not good. So simple. So this is what is actually called a reflexive axiom, and the empirical understanding is what I said. Okay, so a first criteria is the reflexive axiom. So once you say that the individual has to identify the commodity, and if they say some attributes, and then that attribute has to prevail. So this is what is called the reflexiveness. Now the second one, as you people said, the uh, uh, connective axiom. That is, if you say that at least two commodities, so like X and Y is there, then you say that either X and Y, you make a preference out of X and Y. So that's it. That's sort of the connectiveness of the X and Y. X is either related to Y, or Y is not related, neither of it is related. So you have to make a connection. Then you have completeness axioms. Then this is actually in a simple verbal explanation I'm doing. So completeness characteristics, as I said, A and B are any two situation. An individual can always specifically exactly one of these possibilities say that A is preferred over B, or B is preferred over A, or A and B are preferred, or none of it are. But if the moment you say that none of it are it is preferred, then there is an issue that it is not complete, because the thing which you are talking and the preference you are talking is two different things. So it is not complete then. Okay, so what you have to do is you have to restrict yourself that either you have to prefer A or B or both. Then only you can say that the choice set is connected. Okay, or the commodity or the set, the elements in the sets are connected. So this is very, so as well as complete. Okay, so you have to have a connectedness as well as completeness characteristics, which is almost it is not one the same, it is two little different. So just like the reflexive axiom, these are actually the axioms which makes a person to identify the commodities in the set or preference, whatever they do have. So then and then only the person is called a rational person. Okay, when you say that an apple is an apple, then we can say that your mental conditions are okay. All right. Now, if you ask the same question, if I can also twist the same thing. If for me, a glass of water is actually a glass of water. For a chemist, it is not actually a glass of water. So we don't actually, they have actually chemical compounds. They see things in a chemical compound way, hydrogen and oxygen molecules. So whatever. So we call it something else, but we are trying to say this particular point. So same the case with 1 plus 1 is 2 in mathematics, but at the same time in semantics 1 plus 1 is not 2, because 1 plus 1 is actually gives a different sort of symbols. So in semantics people say that this is 1 and 1 plus 1 is not equal to 2, so something else, it is something else. Okay, this is literally many people had actually said that, okay, 1 plus 1 is not actually a 2, it is a big one. So somebody said that, like, if you draw 1 2 1, then you get a big one. Okay, so these are called different. We are not talking about these differences. What we are trying to say is actually we are trying to rationalize it as a mathematical way, which people said 1 plus 1 is equal to 2. Once you identify this kind of a logic, then you say that that particular person is belongs to that particular stream of understanding. So this is what is called the standardization, I mean. All right, and this is very very important as far as the conceptualization as well as understanding the problem of economics or the decision making is concerned. So when you have this multiplicity allowed inside, then you may not actually get a sort of result which is predicted. So this is what is actually the problem. Now then another famous axiom is called the transitivity axiom. So and I think most of you are aware of it. Transitivity is nothing but the shorter form. If you have only three choices, then you call it as a transitive relation. If you have more than three choices, then it is called the cyclical or acyclical problems. Okay, so transitivity is nothing but it is a preference relation. Again, it is an ordering relation. It says that A is preferred to B and B is preferred to C, and all three are there in the set. Okay, so if you are saying that A is preferred to C, B, and B is preferred to C, then automatically you are trying to say that the A is preferred to C. So this is what is called the acyclic relation. I said it is acyclic because in this case it is only three elements are there in it. If you have more elements in the set, then the same logic will follow. Then it is comes under the acyclic parameter, or the otherwise the reverse would be the cyclical parameter or the intransitivity problem. Okay, that means the moment somebody say that A is preferred to B and B is preferred to C, and then there says that C is preferred over A, then you are saying that your decision is not consistent because it is cyclic, circular. Okay, intransitive relation. So assume that the individual's choice are internally consistent. In order to make your choice or having a pattern, you have to always say that, if I like apple over orange, orange over grapes, then you have to say that apple over grape over apple. So that is a kind of a problem. Okay, we are trying to make. So if I am saying that apple is good than or apple is as good as orange, but I like apple, at the same time you are also saying that orange is as good as grapes, then you say that still I prefer orange. Then you are this, as per the transitivity case, you are saying that apple is being preferred over grapes. So this is what is called as a transitive relation. Otherwise, it is called an intransitive problem. Or in a larger set, if you have more than three elements in the set, 4, 5, 6, 7, then you can have actually different bundles of these three choice bundles, and then you can say that there is a possibility of a cyclicity in the case. Otherwise, if it is transitive, then your acyclicity has to be followed. So these are then you have again another set of axioms which is also trying to say that the preference should be continuous. Again, this is very important because, as I said, when you have only three elements, it is easy, but when you have more than three elements, we will be coming to that example very soon. So there also your continuity is important. So A is preferred to B, then situation close to A must also be preferred to B. So this is what is called the continuity axiom, try to say. So once I am saying that A is actually good, as good as B, but you are preferring A, then there is an issue that anything which is very close to A can also be preferred over B, and anything which is close to B is not preferred over A. So this is actually kind of a continuity which gives you a sort of our indifference curve analysis so more smooth. So I'll come to that point a little later. So this is something interesting because and a practical example of the same is the following. Like when you want to have sugar in your tea, one grain of sugar makes no difference for you, right? An addition of one grain sugar or a subtraction of one grain of sugar may not be making much difference, but in fact it do have an effect in the sweetness or sweetness of the tea or coffee or whatever, right? Or whatever food beverage you are having. uh, However, you don't mind that adding one grain sugar or lessening one grain of sugar. So this is what is actually called the continuity axiom. But at the same time, if you say that if you, as I said, if the same thing is actually going to have the effect of the transitivity problem, like then continuity and transitivity is there, then too much of it, if you actually make it different bundles and all, and still at the end of the day you may not be actually liking it, because at the end of a long chain of action, the grains would actually mount to spoons or pinch or larger, whatever quantity, then that may not be actually preferred by the individual. Then it is actually breaks this sort of cyclicity axiom or the transitivity axiom, etc. So there are problems, but that problems we will discuss in the end, not now. So these are the point of cautions which anyone has to have. So at the same time, continuity axiom is very, very important one, because it's a logical one. That is, if you prefer A, then anybody near to A also comes under your liking group. So this is what is actually simply trying to meet, simply try to bring inside the rational choice framework. So used to analyze individuals' response to relatively small changes in the income and price. So that is why the rationality of continuity has always been playing a very important role. Now, all these axioms like a reflexive, connected, transitive, continuous, as well as reflexive, connected, transitive, and continuous case we follow, then you will maybe have a sort of preference which has been given in this following graph. This is the graph which you can see from Haller variant chapter 3. Okay, so in that chapter 3, first graph is this one: weak preference set bundle referred to x1, x2. Okay, so that is this particular graph to do. And now this graph, all of you are very familiar with. Now, മാറുന്നില്ലേ? ആ കാണുന്നില്ല? ഇപ്പോൾ നേരത്തെ ഒന്നും കണ്ടില്ല? Okay, then why you people haven't said anything about it? Okay, this is the slides which I was trying to make. Okay, all the points which I said. So you have to have a completeness axiom other than the reflective connectedness axioms. Then you also have transitivity axioms and continuity axioms, which we have already mentioned, right? Now, if you follow all this thing, then you will be having this particular graph. Okay, if we normally assume that a particular person is having all that or satisfying all the conditions which we said, then his or her preference relation over an x and y or x1 and x2 is going to be formed a preference pattern. So now in the two-dimensional vector space, it is very simple, right? Look at the two-dimensional. You have x1, a different variety of x1 is actually given on the x-axis, as well as in the y-axis you have x2. Okay. Now consider these are actually apples and oranges. Okay. So you have actually different types of apples, same red color apple, and maybe apple means for us a certain object which is immediately come in or comes into our mind. So that is what I am trying to envision. So you have different types of apples in x-axis and x1 axis, and the x2 axis you have different types of oranges. Now all orange, if I, as I said, all the reflexive axioms are there, then all oranges having the same size, same color is orange by itself, and apple, in the case of apple by itself. So reflexive axiom has been satisfied. And then as a person who are going to choose also for him or her, or she or z or he, this same is actually the case. Okay, so apple being identified as apples and orange are identified as oranges. Now if that is the case, then you can have this two-dimensional vector space, and then you can throw all the apples and oranges, then you can actually have different preference patterns. Now if you have this preference pattern, then that is actually going to be exactly like the shaded area. Okay. Now out of that preference, now I said you can pick one apple and an orange. Now all the apples are actually looks alike, as well as maybe having the same taste. And taste we can't say, because unless you bite the apple, unless you choose the apple, you cannot say that actually what is the taste of the apple. Okay. So the same size, same color, same everything is looks the same. Look is actually the similarity. All the apples having the same look and similarities, but the taste part we are not actually assuming here. Why? Because taste you can taste if and only if you choose and after tasting it. Okay. Therefore, I'm not interested to go there. So now you have different choices. So different types of oranges with the same size, as well as the apple with the same. So I am throwing you all the options now. These are called your preference set. Okay. So same type of an apple, same type of an orange. Either you can pick two, and I am giving you an option of you can pick any of the two. So you can have any direction of. So there is no restriction of domain here. So, but you have only two apple or an orange or both can be picked up. So these are called the preference set. Okay. So if you can imagine, this is how a preference set looks like. Now, out of that, you pick two. Suppose Abhirami picks two oranges. Then Yusuf picks two apples. Then Aishwarya picks maybe another an apple and an orange. Then someone else picks an orange and an apple. So you make a different sort of preference itself. Okay. Now that forms the preference that forms in fact a kind of an curve, indifference curve, which is actually exactly gives you the same level of utility. So this is what is actually the Bolden curve, all right, of an x and y, x1 and x2. So either you go for two apples or two oranges. Now if that is the case, then you strictly go for the x2 or x1 or both, then it touches actually. So now when you have the indifference curve analysis, we would have a sort of an assumption says that it never touches the axis. Okay. That means the other commodity cannot be zero. So this is the most important restrictions we will be bringing in. So I'll come to that part later. Okay, but now you know what is actually a preference set looks like, as well as you can actually keep doing it. Now out of that, if 10 people are there, then you have 10 dark point like x1 next to here. So that forms, as I said, a different point, and if you connect that ogive, then you with that points, then you will get an ogive, and that ogive is what is called your normally the indifference curves looks like. But if you have an assumption of a smooth curve kind of continuity axiom inflicts inside, then you will get a smoother curve. So I'll come to that all in details later when we study more on preference and preference functions, etc., all other aspect. Okay, choice, etc. So now, as I said, there are different restrictions. But once you make all these assumptions, it is also try to say that you cannot have actually crossing of two indifference curves. Why? If x is indifferent to z and x is equal to z, x is indifferent to z means what? X is equal to z, and y is indifferent to z is also equals to that y is equal to z. Now in this case, indifferent is not equal. So normally people try to say that I am indifferent to apple, to orange. Never say that apple and orange are one and the same. Okay, they are two distinct elements in the set. So that's what I said. Maybe their utility wise they are same, but not actually by their characteristics. Orange is orange, apple is apple. As I said, we should first consider the fact that apple is apple and orange is of orange. This is what is actually allows, this is the assumption of reflexivity is actually allows us to stick upon this point. Apple is being treated as apple and orange is being treated as orange. So once you say that A is equal to B is equal to C, but A, B, C are different thing. However, from the utility frontier or from the utility point, you can say that actually A is indifferent to B, indifferent to C. Not A is equal to B is equal to C. Why? Mathematically, if I would like to say that A is equal to B, then that is actually what I am trying to inculcate is the following fact that A is having all the characteristics which B is having, and B is having all the characteristics which A has. Okay, so in a simple sense, A is having all the characteristics which B has, and B is having all the characteristics which A has. Then and then only you can say that A and B is equal. But in this case, we are not say that apple and oranges are actually same, but utility terms they may be having, giving, or it is maybe gives you the same level of utility. Not actually because A and B are one and the same. So distinctiveness of the commodity is very, very important as far as this particular assumptions or this terminology of indifference is concerned. Because I can be indifferent, but I am not that my indifference is not equal not attributes anything whatsoever that I treat both A and B are one and the same. So this is what is the difference. Hence A is equal to Y is equal to Z. However, X lies below the steeper indifference curve, meaning X is inferior to Y, which is a contradiction. This is what is actually the problem of an indifference. We'll come to that. That is this particular graph is the proof of all. Not in fact, no graph can be used as a proof, but you can understand how it is mathematically. We can prove it. Okay, so here look at the two diagram, that is XY set and ZY set, where X, Y, Z, see X, Z and Y is actually crossing. Now there is no X exists in the ZY. At the same time, there is no Y exist in the XZ graph. Okay, or that means something which is not exist in the set cannot be used. I'll come to that problem when I'll talk about the Amartya Sen's axioms and all. So I'll come to that later. So anyway, this cannot be cross. If you have this problem, then as I said in the earlier thing, you will be misunderstanding things in a very different way. So some special preference, as we had pointed, that is goods are perfect substitute. These are the things which you have already studied, right? Perfect substitute, complementary goods, perfect complementary goods, and a not perfect complementary, not perfect substitute, etc. So then you have a neutral good, then say shifted preference, discrete good, etc. So let's see what are these things. So normally all of you had come across this particular concept like perfect substitute. Okay, what is a perfect substitute? Perfect substitute has it means that every point, every utility of X can be replaced as by Y. Okay, there is no making to be very understandable point as of a demonstration. You can say that no point whatsoever can be left out by another commodity. See, there is no void exist in that. So anything can be replaced by the other thing. So X can be replaced exactly with the same quantity, same. But in real world, when you talk about productivity, labor productivity vis-a-vis capital productivity, you can't exactly switch the unit of labor vis-a-vis the unit of capital. So capital and labor may not be exactly the perfect substitute in that, but maybe it is having a substitutability, but that is not necessarily a perfect substitute. Okay, so that is what, if it is a perfect substitute, then the curves looks like this thing. Okay, straight line. That is every point of an x1 from the next unit, y1 can x2 can be replaced with. So then you can have the straight line. Otherwise, you will have a curvature. That is what is the indifference curve try to say that. That is actually the substitutability. If the substitutability is imperfect, then you can have actually different points of inflections you can see from the what you can say substitution. Okay, so if it is in the same straight line slope, that is in the downward sloping curve, which is showing in the figure 3.3, that imply that the substitute, the rate at which you change from one commodity to another, that is x1 to x2, is exactly the same. So you have no uh, um, glitches here. So then your substitution is called the perfect substitution. Otherwise, it may not be a perfect substitution. Now, this is what is we said the complementarity, perfect complementarity case. So you say that if you have a left shoes and right shoe, provided that you have two legs, left and right. Okay, that's also very important. So when you say that you have a left shoe and right shoe, if you have two legs, then you have to wear two shoes to have a perfect left and right shoes. Okay, so either if I give you many left